Okay, so if you're going to be taking any algebra classes beyond this one, you're going to have to learn how to graph a linear equation. And there's a few steps here that you can read through. I recommend that you hit pause, read through these, and then I'll explain them in just a second. Okay, so if we're going to graph the equation y equals negative 3x, we're going to create a table and we get to pick whatever values we want to put into our table. My recommendation is always use values that are nice to you, that make your life a little bit easier. So if I'm going to put in numbers that are nice to me, I might choose 0. For x, I might choose 1, and I might choose negative 1. Now, again, those numbers came out of the air. I just pulled them out of the air. I could have picked any number that I wanted to. I could have picked 2 or 3 or 4. I could have picked anything. These are just numbers that seem to be fairly friendly numbers. So if I'm going to put 0 in for x, I've got y is equal to negative 3 times 0. So then y is equal to 0. So whenever x is 0, y is also 0. So that right there is an ordered pair, 0, 0. So I know I have a dot here at the origin. Actually, I'm going to make that red so it sticks out a little bit better. Okay, now I'm going to try positive 1. So I've got y is equal to negative 3 times 1. So y is equal to, what is negative 3 times 1? It's negative 3. So whenever I plug in 1, when my input is 1, my output is negative 3. So I can put a dot there at 1, negative 3. Now my last point that I'm going to graph here is I'm going to put in negative 1. So y is equal to negative 3 times negative 1. And what is negative 3 times negative 1? It is positive 3. So I have an ordered pair at negative 1, positive 3. So negative 1, positive 3 is right here. And so then what you want to do is you want to grab a straight edge and you want to connect your dots. And always draw your arrows at the end, because that line does go on forever. Remember how I said that I could have used any other numbers? Well, if I had put in 2, I would have gotten out negative 6, which would have put another dot down here. And so you just want to make sure that all these dots line up. And so they do create a line. So notice all 3 of those do lie in a straight line, and so that right there is the graph of y equals negative 3x. Okay, on this one, y is equal to 1/2 x plus 3. Now, on this one, I might pick some different numbers for x, just because I'm going to pick other numbers that are nicer to deal with so that I don't get fractions as answers. So, I'm going to pick values of x that make my life easier. Oops. Okay, so 0 is always a friendly number, so I'm going to pick 0. And so whenever I put in 0, I've got y is equal to 1/2 times 0 plus 3. 1/2 times 0 is 0. 0 plus 3 is 3. So my ordered pair is 0, 3. Now, if I put in 1, 1/2 times 1 is 1/2. So I'm going to wind up with a fraction as an answer. But if I put in multiples of my denominator, then the fraction goes away. So I can easily take half of numbers like 2, 4, 6, 8, and I end up with whole numbers. So I'm going to put in maybe 2 this time. So I've got y is equal to 1/2 times 2 plus 3. Half of 2 is 1. 1 plus 3 is 4. So I have an ordered pair at 2, 4. Now another number, I could use negative 2 if I wanted. I could use negative 4. If I'm a person who doesn't like to deal with negative numbers, then I might choose 4 here. So y is equal to 1/2 times 4 plus 3. Half of 4 is 2. 2 plus 3 is 5. So I have an ordered pair at 4, 5. So now I'm going to go ahead and graph these. 0, 3 is up here. 2, 4 is right here. And 4, 5 is right here. And again, grab a straight edge or a sheet of paper or something just to make sure that they do line up, and it helps you draw your line just a little bit better. Don't forget to put arrows at the ends because that line does go on forever in both directions. So this right here is the graph of y is equal to 1/2 x plus 3. Okay, with a problem like this, there's several ways that we can actually do this. We could leave it in the format that it's in. So I could just pick values of x, and I can pick values of y that make my life easier. So if I put in 0 for x, I've got 0 plus y equals 5, therefore y is 5. So I've got 0, 5. But in this format, it's just as easy to put in a number for y. So what if I put in 0 for y? I'm going to work backwards just a little bit, but I've got x plus 0 equals 5. Therefore, x is 5. What we just found are the intercepts. That's where it crosses the x-axis and the y-axis. Now I can put in anything I want, either for x or y. So if I put in, let's say, 1 for x, I just pulled that out of the air. I've got 1 plus y equals 5. So then I would subtract 1 from both sides. So I've got y is equal to 4. So when I put in 1, I get out 4. Now let's graph these points. 0, 5 is right here. 5, 0 is right here. 1, 4 is right here. So now, grabbing my straight edge, I'm going to connect my dots, draw my arrows at the end, and this line right here is the graph of x plus y equals 5. Okay, for this problem, it actually might be easier if we turn this into something that looks like y equals something. So I'm going to change the format of this equation so that I have my y all by itself. So I'm going to move that 3x from the left side to the right side of the equal sign. Whenever you move something, you have to do the opposite of it. Now, 3x minus 3x is 0. It goes away. So I've got y is equal to negative 3x minus 1. Notice I didn't combine those. They're not like terms, so I cannot combine them. So now I'm going to put in values for x that make my life easier and see what I get out for y. Okay, so I'm going to plug in maybe 0. 0 is always a good one. So y is equal to negative 3 times 0 minus 1. Negative 3 times 0 is 0. 0 minus 1 is negative 1. So I've got 0, negative 1 as an ordered pair. Okay, so another number, because we're not dealing with fractions, we really don't care what number we pick. Another number that we might choose maybe would be 1. So y is equal to negative 3 times 1 minus 1. Negative 3 times 1 is negative 3. Negative 3 minus 1 is negative 4. So 1, negative 4 is an ordered pair. And I might choose negative 1 in this case. Could I have used 2? Yeah. So we've got y is equal to negative 3 times negative 1 minus 1. And negative 3 times negative 1 is positive 3. Positive 3 minus 1 is 2. So I've got negative 1 and 2 here. So now to graph these, I've got an ordered pair at 0, negative 1, 1, negative 4, which is right there, and negative 1, positive 2, which is right there. Grabbing the straight edge again, I'm going to connect the dots and draw the arrows on the end. So this line right here is 3x plus y equals negative 1. Okay, vertical lines. Vertical line only has, if you think about it, if I were to draw this graph here, and here's my x-axis and here's my y-axis, if I draw a vertical line, all vertical lines only cross the x-axis. Therefore, they can only have an x in their equation. So the graph of this line right here could be x equals 2. All vertical lines only have that. They do not have a y in their equation. Okay, so if we're looking at x equals 2, if you were to make a table, then no matter what you get for y, x will always be 2. No matter what. So if I put in 0, x is 2. If I put in 1 for y, x is 2. If I put in 3 for y, x is 2. So these right here are my ordered pairs. So 2, 0 is right here. 2, 1 is right here. 2, 3 is right here. And notice what I got. I got a vertical line. This right here is the graph of x equals 2. Notice there is no y in this equation. It cannot cross the y-axis if it doesn't have a y in the equation. Okay, so now let's talk about horizontal lines. So we've got, this is our x-axis, this is our y-axis. If I were to have something that looks like this, the equation of this line could be y is equal to negative 1. Notice there's no x in the equation and it does not cross the x-axis. So all horizontal lines only have a y in the equation. Okay, so if I have y equals negative 1, no matter what value I put in for x, y will always be negative 1. So I could put in 0, I could put in 2, I could put in 4, I could put in 5 if I wanted. Anything for x, no matter what, I get out negative 1 for y. So 0, negative 1 is right here. 2, negative 1 is right here. 4, negative 1 is right here. And 5, negative 1 is right here. Notice I get a horizontal line. Never crosses the x-axis. Okay, I threw this problem at you because I wanted you to see the difference between y equals negative 3x and y equals negative 3. Notice this one does not have an x in the equation. No x in that equation, but this one does. It's got an x and it has a y. That means that it has to cross the x and the y axis somewhere. So let's look at the first one. So I'm going to put in 0 for x. So my y is equal to negative 3 times 0, which is 0. So I've got 0, 0 as an ordered pair. If I put in 1 for x, I've got y is equal to negative 3 times 1. That is negative 3. So I've got 1, negative 3 as an ordered pair. If I put in, let's say, 2, I would have y is equal to negative 3 times 2, which is negative 6. So I've got 2, negative 6. So I'm going to graph that real quick. 0, 0 is right here. 1, negative 3 is right here. And 2, negative 6 is down here. Okay, so grabbing the straight edge, I'm going to connect my dots and draw my arrows on the end. Okay, so the other one I'm going to do in the purple color. So y is equal to negative 3. Notice there's no x at all in this equation. So no matter what I put in for x, I get out negative 3 every time because there's no x in the equation. So I've got an ordered pair at 0, negative 3, 1, negative 3, and 2, negative 3. And so I get a horizontal line. So do you now see the difference between y equals negative 3x and y equals negative 3?